An immensely important subject during your S2 training is managing correct separation between your airplanes. You see, you need a structure and you need to know the rules of how to avoid airplanes crashing into each other, both on your airport and also after they're airborne for the controllers around you. Therefore, we will now look at all aspects of separation. There are 5 types that we want to go through and make sure you understand. Ground separation and runway occupancy, route-based separation, wake turbulence-based separation, performance-based separation, and finally, parallel operation. Of these 5, the first stand out, because it's not really officially separation. Separation is generally for airborne flights, but we do include this here for the sake of simplicity to just clear out a few things. So, what are we talking about here? Ground separation is pretty quickly penned. Do not taxi, do not push, and do not pull airplanes into each other. An airplane cannot be pushed back into the taxi path of another airplane, and you cannot ask 2 or even 3 airplanes to follow the same path of taxi if it leads to them taxiing into each other. First, one has to go, while the 2 others are holding at a place which will not infringe the path of the first one, then the next one can go, and then lastly the third one can go. With a pushback, that means waiting, or give a conditional clearance. With taxi instructions, it means systematically giving hold short instructions to other airplanes. Again, once both are in view of each other, then the problem can be solved with a conditional clearance. Remember the ATS instruction 14, you can also ask for one to give way. It is the same when it comes to the runway. You can't just say line up and wait to all the airplanes that's at the runway and waiting in line. One at a time, after which the first one leaves, the next one can line up. Again, possibility to use conditional clearance, subject to the restrictions as discussed in that particular chapter. This brings us to the next part, which is way more interesting. Runway occupancy. There's basically a few simple rules. When an airplane has been cleared for takeoff or cleared for landing, the runway ahead of it must remain clear. It's even in the clearance, the runway has been cleared for takeoff or cleared for land. This means from the moment you've issued a landing clearance or takeoff clearance, nobody may enter, cross, or low-pass fly over the runway. This means certain rules for what you are allowed to issue, especially when it comes to the landing clearance, and more specifically, when you're allowed to issue the landing clearance. So let's go through them all now. Landing after landing. The preceding has to be vacated past the stop bar before you issue the landing clearance to the next one. Landing after takeoff, well, the departing airplane has to be airborne and either pass the opposite threshold or have a turn commenced before the landing clearance can be issued. The latest you can issue a landing clearance can be found in Doc 4444, and the definition is very important. So look, a landing aircraft will normally not be permitted to cross the runway threshold on its final approach until the preceding departing aircraft had crossed the end of runway in use or has started a turn, or until all preceding landing aircraft are clear of the runway in use. What does this really mean? This means that the clearance to land must be received by 50 feet, because that's where the runway threshold is. If the runway is not cleared by that time, you must issue a missed approach to avoid the pilot going past the 50-foot marker of the runway threshold. You do this by saying, Lufthansa 9 Papa Kilo, go around. Note that while departing airplanes must pass the opposite threshold before landing clearance can be issued, this is according to Doc 4444, and there may be different procedures or exemptions in place for local airports. When it comes to takeoff behind landings, well, you may issue a takeoff clearance when the landing traffic is vacated, just like landing after landing. That leaves us with the all-important takeoff after takeoff. And that takes us to the next part of this presentation, the actual separation, the airborne kind. Mainly, it's used for departures. First of all, don't confuse this with radar separation, which is what approach is providing using routings and vectors and so forth. This is not what you provide. You more specifically provide separation as per ICAO Doc 4444, which has a lot of complex rules, and I'll try to break them down for you the best I can. To set matters straight, there is a baseline for how much separation 2 departures need. Point 792 is stating a departing aircraft will normally not to be permitted to commence takeoff until the preceding departing aircraft has crossed the end of the runway in use or has started a turn, or until all preceding landing aircraft are clear of the runway in use. Meaning, when Scandinavian 18 X-ray has passed the opposite end of the runway threshold, the next takeoff clearance for Austrian 306 may be issued. This is roughly 1 minute of separation and is also in line with the minimum allowed separation between departures in all airports in Denmark. Now, from there on, there are quite a few extra additions depending on different criteria, and that is what makes it tricky. Remember, this is the baseline, and you should send with this unless the following conditions require differently. We will deal in these three: separation based on route, size, and performance. All important techniques which you must master from the beginning, so it cannot be overstated enough how important this is to understand. Point 791 in ICAO Doc 4444 states the facilitations that are to be taken, and those are performance, routings, wake turbulence. We begin with the one you see the most, the route-based separation, because this is the fundamental one. It doesn't matter what aircraft type, doesn't matter the speed, doesn't matter anything else. It's all about the routings that's followed after departure. So the question in here is if the routings are diverging more or less than 45 degrees after departure. If they diverge more, then no problem. You provide 1 minute of separation But wait. So you may be confused now, because I just said that it was the opposite threshold that was the minimum. So where does this 1 minute come from? Well, ICAO Doc 4444 rule, passing the opposite threshold, that is something for everybody. Doesn't matter if you're VFR, RFR, or whatever. 1 minute separation you're seeing here, this is also the minimum required for routing separation between IFR departures. As luck would have it, passing the opposite threshold and 1 minute is actually exactly the same. So if you give a takeoff clearance to the trailing after preceding passes the opposite runway threshold, that will fit with 1 minute. Easy. So if they diverge now then less than 45 degrees, then you have to have 2 minutes in between them. Good. Let's stop for a second. 2 minutes between what? Good question. 2 minutes between the first one rolling and the second one rolling. And instead of timing, you can also see that once the preceding is passing 2 nautical miles from the opposite runway threshold, then you can give the next one a takeoff clearance, and that will fit with 2 minutes. This is just a tip. So, if 2 airplanes have the same SID, they need 2 minutes. In Billund, for example, all SIDs diverge more than 45 degrees, so that makes it pretty easy. In Copenhagen, you'll find it be a lot more complicated because you have SIDs which are spaced less than 45 degrees and therefore require 2 minutes in between each other, and you have so much traffic that it's really essential to get them rolling as quickly as possible. You need therefore to choose which departure you send, when, in order to delegate them as well as you can between the directions. You see here, for example, in Copenhagen, you have 5 groups of departure, so send them in between each other. And yes, you are free to do this. According to point 633 on departure sequence, it allows you to deviate in order to minimize average delay. Good. Second thing to consider is wake turbulence separation. This is extra separation based on the wake turbulence class of the airplane, which varies with the weight. See, when an airplane takes off, it produces lift, which pushes airflow to the edge of the wing, which produces a wake. And these wakes may be dangerous for other airplanes. The heavier the airplane, the larger the wake, the more danger. The smaller the airplane, the more susceptible it is to wake, and therefore extra time needs to be added in order to allow the wake to disappear. There are 4 categories of wake turbulence to consider: light, medium, heavy, and super, separated at 7,000 kilos, 136,000 kilos, and as per ICAO Doc 8643, not important. Where does that put different airplanes? Well, this is a hard thing to learn, but to make it as simple as possible, light airplanes, they are really light. They are Cessnas, Pipers, Zeros, Caravans, TBMs, these kind of airplanes. Mediums is a very broad category. They are as small as Citations, ATRs, and Dash 8s, and they're all the way up to 737s, A320s, and such airplanes. Heavies are the long-haul airplanes, 767, A300, A330, 747, 787s, these kinds. And all other of that size, super is a special category with no weight limits, but just defined in this ICAO document and reserved at this point only for the Airbus A380. That's it. And you can often pretty easily guess which category can be used. Just one airplane is interesting and must be highlighted. It's the 757, which actually employs 2 categories. It's both a medium and a heavy. What that means operationally, I will have to get back to. You see, there are a lot of rules concerning this, but the most important thing you need to understand is the fundamentals about wake turbulence. It's about the size of the wake being produced and how sensitive the aircraft is to those wakes. And that both of these are proportional to the weight, but in each direction. If the weight of the aircraft is higher, the size of the wake it produces are bigger and the sensitivity to them are lower because heavier things are more difficult to move. On the other hand, if the weight is lower, then the wakes produced are smaller and the sensitivity towards them is being higher. That's why the critical situations are light airplanes with high sensitivity to wakes departing behind large airplanes which produces strong wakes. And so there are a lot of situations depending on runway configuration, place of departure, opposite, crossing, offset, and so on. Does it sound complex? It is very much so. The good news though is that for 95% of the time you only really need to know two values, and for the rest of them they are so rare that we barely bother teaching them to you anyway. You can read them up yourself. In 95% of the cases you need to react when you have an airplane departing behind a heavier aircraft within the conventional categories. This means all cases. It means light behind medium, it means a medium behind a heavy, and even a light behind a heavy. It's all the same. If an airplane takes off and the next airplane is of a lighter category from the same part of the runway, then you need to provide 2 minutes of separation. That's the first number. If, on the other hand, an aircraft takes off and the next airplane is of a lighter category from an intermediate part of the runway, an intersection, then you need to provide 3 minutes instead. That's the second number. This is based on the principle that the heavier airplane lifts off later, which is the point at which the wake begins. If the lighter airplanes start to take off roll further down the runway, then it's more likely to hit the wakes at a critical phase when it's still very close to the ground. 2 minutes from the same part of the runway, 3 minutes if from an intersection by the lighter one. Secondly, I promised I would come back to the 757, which employs both the medium and heavy category. If it's the first plane, like here, it's treated like a heavy and wake turbulence separation must be added. However, if it's the trailing airplane, then it's treated as a medium, meaning it needs 2 minutes behind the heavy. It's pretty impractical, but that's how it is. You may be thinking, what about landing airplanes? Are there no wake turbulence separation there? And yes, there is, but it's translated into miles and it will be the job of the approach controller to sequence them in appropriately. This is also specified in Doc 4444.873 and is mostly S3 stuff. You just need to remind them by saying caution wake turbulence. By the way, there is no wake turbulence separation between an arrival and a departure because wake stops the moment the airplane hits the runway and the wings don't produce lift anymore, and that's not really anything for the departing. So in essence, let's just get an overview and include the super category, the A380, as well. If preceding and trailing airplanes are of the same class of the trailing or bigger, it's just 1 minute. If the trailing is lighter, it's 2 minutes. And if a medium or a light is behind a super, you need to add an extra minute, so 3 minutes. If we look at takeoff by the lighter category from the intermediate part of the runway, we then add 1 minute to everything. 2 minutes becomes 3 minutes. 3 minutes by the medium and light behind the super becomes 4 minutes. Now, what about the next one? Performance separation. This is not so much a question about weight or routing, but a question of propulsion. While there are plenty of exceptions, in essence, propeller airplanes are much slower than jet airplanes. And if a slow-moving airplane is departing behind a fast-moving airplane, then yeah, you will have a problem. Therefore, we also add 2 minutes again if you want a slow-moving airplane to depart ahead of a fast-moving. An alternative is to just turn it away from the path of the second one, and then you won't have the issue. This is mainly used for larger propeller airplanes such as the ATR and Dash 8, or just small propeller airplanes that generally flies very slow behind very fast-moving jet airplanes. Lastly, we need to talk about parallel runway operation and what you are allowed in regards to these separation methods. We will use Copenhagen as an example because this is the airport you will mainly use and it also has some uniquely spaced runways. When it comes to the route-based separation, especially one demand from Doc 4444 is very controlling. That's this one. Departure paths must diverge at least 15 degrees immediately after takeoff. They do not do that in Copenhagen or in any other place in Denmark, and therefore we may not consider parallel runway as independent for departures. You must treat a departure on runway 22 right and runway 22 left as one runway and separate as you would if they had departed from the same runway, with 1 minute between SIDs and making sure that one is passing the opposite threshold before the next one gets the clearance. When it comes to the other parts, you have actually 3 different types of parallel runway operation: independent, dependent, and segregated. It's specified in Doc 4444.673. Independent parallel approaches is something you can see in big airports such as Madrid, Los Angeles, Frankfurt, and Munich, where the runways are spaced far from each other. More specifically, spaced 1,525 meters, but never less than 1,035 meters. Copenhagen is no way close to that. In fact, in Copenhagen you only have 590 meters, so independent parallel approaches are not allowed. However, dependent parallel approaches are allowed in Copenhagen because it doesn't matter the spacing between the runways there. What is it exactly? Well, it is that you can go down to 2 miles of separation in between flights if certain conditions on the ILS equipment and so forth has been fulfilled. The further spaced the runway are from each other, the more parallel they can be, because you measure the separation in a direct line between the airplanes. This is also the responsibility of the approach controller. The third one is called segregated parallel operation and has to do with landings on one runway and takeoffs on the others. Maybe already now you're thinking, hey, that's something we do in Copenhagen, and yes we do. According to Doc 4444, to perform segregated operations, the runway's missed approach track must diverge more than 30 degrees, which it does. Secondly, you need 760 meters between runways and, well, actually we do not have that. However, there is a condition, which is when the runways are staggered, meaning that they are offset. For every 150 meters they're staggered, you may reduce the required distance between them by 30 meters. The runways in Copenhagen are very offset. They're actually 1,500 meters staggered, meaning the requirement is reduced by 300 meters, and so we are again within the limits. So that's why you are allowed to depart airplanes and land airplanes in Copenhagen completely independently of each other. But remember this one, they must be 30 degrees offset always. That means when you have a go-around, you must make sure the go-around is following that left turn that it needs to do in order not to infringe the departing airplane. This limit must be respected. So that's the most important part of the separation covered. This is a big topic and is a very important topic. Ground separation, route separation, wake turbulence, performance, parallel operation. It's a lot of stuff, so keep reading, keep studying, and keep up the good work. Thanks for watching.